Seems we are live. Pretty exciting. I hope we are live. So, saw this comic where before as a presenter you could see people, and now I'm probably by myself. There's nobody there, right? But I guess it's time, so let's start with the intro.
Hi all. Finland Azure User Group Virtual Azure Tips and Tricks Extravaganza to the Max 2020 is here. Welcome. FAUG is about continuous learning and the community around cloud computing and Microsoft Azure. We have over 1,600 members and we organize over 10 events yearly, virtually and in person, of which the largest example is IglueConf, held every January. Virtual Azure Tips and Tricks is a year-long event during which we present several about 30-minute talks about various topics by various presenters. Please tune in to our meetup site to view the upcoming presentations and to our YouTube channel to view the previous presentations. Thank you for joining us and stay safe.
I have no clue what that handsome fella said because I have no sound for him, but he said something, and now we can get started on Azure Cosmos DB, cost optimization and autoscale, part of the Finland Azure User Group Virtual Tips and Tricks thingy, extravaganza. So before we go forward, I'll introduce myself. I'm Sakari Nahi. I'm CEO at Azure and other founder along with Sami Lavikko, our CTO. I'm a Microsoft Regional Director and an Azure MVP. There you can see my Twitter. I'm co-host of this Finnish Microsoft-specific podcast, Ikkuna Studio. I'm a founder and organizer of Finland Azure User Group, and our biggest event at FAUG is IglueConf, held every January. Azure is a company focusing on building solutions on Azure platform as a service and other modern native cloud applications on Azure. We also help organizations take benefit from Azure, and that's all we do. We are about 50 people strong, 50 to 60 thereabouts. We are in Helsinki, Finland, and in Ghent, Belgium, although Ghent's office is pretty small. We started it January this year. We are an experienced bunch. Our people have on average experience of 14 years. Customer satisfaction is nice. We have some Azure MVPs, and employee NPS is, I'm pretty happy about that one actually. What we will speak about today is we're going to fast walk past the Cosmos DB pricing model and the autoscale feature. Then I'm going to tell you about some of the autoscale experiences we've had, and we'll finish up with an optimization story, David's story. And at the end, if you have any questions, feel free to ask those and I'll try to answer what I can. Unfortunately, we won't have time to look at the basics of Cosmos DB. So if you are new to Cosmos DB, hang on, read something afterwards, and maybe you'll get some benefit out of this. The pricing of Cosmos DB is based on throughput and storage mostly. Throughput refers to request units. Request unit is not a single request. It's this unit of cost specified by Microsoft that basically contains all the things Cosmos DB needs to function. Memory, CPU, I/O, and all of that stuff. On the right, you see this creation of a new database and container, and there you can see that you define a throughput when you create a container for your data. And there I've defined the minimum amount of 400 request units per second. And you see that a 400 request units per second database would cost you $23 monthly. To get an inkling of understanding how much request units you would need is the reading and writing of 1 kilobyte document. So reading is 1 request unit. And remember this, we'll come back to this later. So reading 1 kilobyte document costs you 1 request unit, and writing one costs you 5. The storage is billed at 25 cents a gigabyte, meaning that if you have 100 gigabytes in the database, it will cost you 25 USD. There are some relationships between the storage and the request unit amounts and so forth, but let's not go there. Autoscale, however, is a new feature. Autoscale means that if you put that scaling on, it scales instantly according to demand directed at your Cosmos DB. And this can be pretty powerful. It scales between an n, a value you given, and 10% of that value. So on the right, you can again see a creation of a container, but this time it's been created as a scaling, autoscaling, with autoscaling mechanism. And there, if the max RUs are 4,000, then the minimum would be 400. And the container would oscillate between that depending on the demand of your Cosmos DB container. The pricing mechanism is the same. Basically, the amount of RUs you spend, they are billed hourly, but there's a 50% markup on autoscale. So basically, if you spend, if your autoscaling container spends 4,000 RU, then it would be the same as your manual scaling container would spend 6,000 request units. That means that if you have a maximum for autoscaling and your container stays at that maximum for more than 16 hours a day, it might be more cost effective to have a manual scaling container instead at that same value for the whole day. Autoscaling is meant to be used, therefore, in unpredictable workloads. So when you don't know how your container will be queried or written to or asked about by consumers, then you will think about autoscale. If you can predict the workload, then you should think about using manual scaling and schedule it. Our experience on autoscale have been pretty good. It's pretty responsive. It's very fast. You don't have to worry that you get queries and the database wouldn't keep up. It keeps up. But what it also is, it's pretty greedy. And what I mean by greedy is that how can it be greedy when you set up the maximum value? Well, it can, because when you optimize your manual scaling container, you optimize, or you should optimize it to the limit where you still get some 429s, meaning too many request errors from Cosmos DB. You should not try to optimize to a limit where you don't get any too many request errors. SDKs by Microsoft handle the retrying, so it's healthy for you to have some 429s, otherwise you are paying too much. Now in autoscaling scenario, the 429s, they don't come until you hit the limit, because if they almost appear, then autoscaling scales higher. So it's greedy. It gets high very fast if the situation so warrants. And that's good to understand. It's good for unpredictable workloads, like I said, but scheduled manual scaling is cheaper for predictable. And you can use scheduling with autoscale as well. Just call the Cosmos DB API and set up the autoscale maximum for, I don't know, for your workday or whatever, if that is the usage pattern of your data, so that it's higher. And then for the night, if it's still unpredictable, you can set the autoscaling maximum to a lower amount. There has been some situations when the autoscaling maximum hasn't worked or sticked. When it's rising, when it's ramping up, it sometimes gets higher than what we gave it, the Cosmos DB, and then it kind of notices, whoops, I went overboard, and then it comes back down. I think that's maybe because the feature is so new. There hasn't been any big risks or issues because of that. It's just nice to notice, or fun to notice, that it sometimes gets a little bit higher. Let's get to the optimization story. It's David's story. David is a developer. He's a sad developer. You can see his picture there. He's not too happy about something. So David's company, David's team, David has a bunch of devices, and he gets told that, hey, you should get the data from devices and put them somewhere. The devices are in sites, and there are thousands of sites. This means that there are tens or hundreds of thousands of devices where the data is coming from. And now David is thinking, where does he put the data? And he finds out and learns and gets told that Cosmos DB, that's a scalable beast. Put your data there and you don't have to worry about performance. So he sets up a Cosmos DB account and starts writing device data into a container that he creates. And he reads that there's no limit to logical partitions. So you can have as many logical partitions as you want, millions of them. So his partition key is just some hash. So he writes every data point from device to its own logical partition, and that's fine, that works. But he leaves the indexing on because he's pretty sure some people are going to come to him and ask for the data. And that happens, of course. A business person comes along and says, hey, I want to query all the data from all the devices on this site. So David's like, oh yeah, I got the indexing on, no problemo. I'm just going to do select from my data, set where site is whatever you tell me to, factory X. And that's nice, in a sense, except everything goes boom. Cross-partition queries everywhere. And that's not good. That's not where you can go when you are building Cosmos DB. If you go cross-partition query, you should go there often. What's a cross-partition query? Cosmos DB partitioning is based on the following scenario. So we have a container. Let's say you've specified 100,000 request units per second for a container, and then you have logical partitions. In this scenario, it was some unique hash for David, so there are millions of logical partitions, which is fine. These millions of logical partitions are stored in physical partitions, and these physical partitions are servers, right? So, and physical partitions, the limit of those is assumed is 10,000 request units per second, meaning we assume there are 10 of those for a 100,000 container. Now, we don't know the amount of these. Microsoft doesn't tell us this. Microsoft doesn't give us control for physical partitions. So Cosmos DB magic logic, cosmical logic does the thing for physical partitions. So that's what happens. Now, if I make a query to a system like this with the site, the query goes everywhere. It hits everything. It goes to logical partition and that's fine, but it dips to all of the 10 servers. And that gets costly and that gets slow and that's not feasible. So what does David do? David goes back to the workbench and he's like, okay, people are reading by site. Let's have the data by site. Partition key site is the change. And then he writes data with the site partition key. And now the reads are fast. It sounds good, but it doesn't work because write's so slow. So what did we do? We went from fast writes and slow reads to slow writes and fast reads. And in some scenarios, I bet that's fine for some of you folks. You might be happy with slow writing or slow reading, but in many cases, they both need to be optimized, like in David's case. So what David does, David upgrades the request units per second to 500,000. So now the write is speedier again. He can just push data and, all of the magic happens. And David's pretty happy because Cosmos DB really scales. It scales to heaven. Problem comes when a business person comes to him and says, hey dude, your database is costing us $350,000 a year. So David's like, all right, guess I gotta do something. So he starts scaling in a scheduled manner. He puts 500K in the morning when it's needed for the writing, when the device data comes in, and 50K otherwise, figuring that's enough for the read scenarios. That's a good assumption, except he finds out that the reads get throttled. Why is that? He thinks that should be enough because the reads are not that complex. So let's look at what happens there. Here we have the partitioning scheme that David has now. So he has 500,000 request units in a container. There are thousands of sites because the logical partition key has changed from unique hash to site. That's fine. And there are 50 physical partitions, 10,000 request units per partition for a container of 500,000. Now what David does, he, in a scheduled manner, he lowers the amount of request units in a container to 50,000. Boom, go to physical partitions. Now he has 50 physical partitions with 1,000 request units per second per physical partition. And what happens is that his busiest sites, the biggest sites where they have the most devices or the most activity or the most active clients who make the most requests, those requests go to a single physical partition because logical partition is always inside a single physical partition, meaning that 1,000 isn't enough. And read get throttled and he doesn't get what he wants and it's a dead end. Now David's come to an end in this way of thinking. And he needs a new architecture. He needs to rethink his approach. So he starts to dig into the diagrams offered by Azure Portal. So this is a diagram of requests for 7 days in 6-hour granularity. And David has 3 main containers he's looking at. He has values container, blue line. Values contains the values from devices. There's the devices container, orange line, and devices contains the metadata and information about the devices itself. And then you have the blue line, the other blue line, the bluer line, darker blue line, sites. And sites has the metadata about sites. And then he looks at the requests and he sees that, okay, values and devices get the most requests, about 1 million an hour. He digs into a tighter granularity, 15 minute, and he sees that there are some spikes, some bursty workloads. And okay, in the spikes, it seems like devices can get about 1 million requests in 15 minutes, while values only get 400,000 in that one spike where the cursor is. So, okay, devices container is getting very many requests. So he turns to request units. And now requests are just requests, while request units are money. Request units are money you pay for Cosmos DB. And he's like, what's going on here? He just saw that devices container is getting double the request to values, but values is spending about, I don't know, is that 5 or 6 times? 6 times the request units that device is using in 6 hour period. So he digs into a 5-minute period and he notices that there's in values container there are spikes of request unit usage that is not apparent in devices. This of course means that if devices get more requests than values, but values spends more request units, it means that devices, queries and calls and usage is simpler. There is something going on with the values container. So he goes to look at the values container. Now this is values container and he split the view by operation type. It's a single day. And he sees that what happens with the container, there are queries on that spike, on that 1 minute period, there is almost 80,000 queries to this container. And then there are a couple of executes in some periods of the day. And it seems like looking at the requests, the executes stay pretty low, the query is pretty stable except for the one in the morning, 6:34. So then he looks at request units, the things that cost once again. It's the same thing, same deal. It's not the query that costs. Note that the colors have changed. The query is now orange. The query cost at that time, 6:34, only amounts to 764,000 request units. And if you look at the executions, there's almost 10 million per minute request units spent in a couple of locations during the day and 5 million on a third spike. And executions are writes because David stores data in Cosmos DB with stored procedures. And those turn up as executions. If he would do writes or upserts, they would be their own operation type, but now he uses stored procedures, so those are executions. And queries are, of course, calls. So now David knows that actually in his Cosmos DB, there is one container that costs 6 times the second one. And in that container, the cost pretty much comes from executions, meaning writes. So David figures he cannot keep on storing device values with the site partition because it's slow and it seems to cause trouble. It's too costly. So he's thinking of a new partitioning strategy. So he goes to the whiteboard and rethinks everything. So he has two different use cases. He needs to write the device data. It doesn't matter how he writes them, he just wants to store them. And he did that at first and it went swimmingly. It was very fast when he just had unique hashes. But then he needs to provide that data to be read by site. So he figures he needs two different partition keys. Makes sense. And for two different partition keys, he needs two different containers because partition keys are container specific. So what does David do? David wants to provide the same capability for reading, so he leaves the read container as is, indexing on partition key site. Then he gets back to what he had in the first stage. He adds a write container where partition key is a data point hash or write hash or whatever, and indexing is minimized in that one because it's not being read, the write container. And now he's got to figure how he moves data from write container to read container in a timely manner. And he comes up with a change feed and Azure functions. Change feed is a Cosmos DB feature that doesn't get billed extra. It uses the request units you've specified, and it also has the same SLA as Cosmos DB, which is nice. Change feed reacts to changes in documents and document creations and triggers Azure function or several to do data, to do operations and processing on that document, like enriching and validating and processing it. And in this case, Azure function gets it, it makes some changes, and then it stores it in the read container. So once David has done this change, he compares the old and the new one. Now we have the old one visible here. It's a single container here where there is write operations and read operations in the same container, where we can see the morning spike now, and write operations use that many request units, and read operations are there for the whole day, but they don't get that high. And this is the two container approach. Here the write is orange, so it gets written stuff, and all the stuff is written into Cosmos DB pretty fast. It's done before 5:30. And then we have the other container that is being pushed data from the write container to read container, which is blue. And that's finished at about the same time as in previous world the single container was. And of course, in this scenario, David can now scale up or scale down either the read or write separately, which makes this architecture a lot better in that sense. So what else does David look at? He looks at how the data is read and written. So this is a fast one. I still have some minutes left. Check out the Bulk support. It's pretty new. It's in .NET SDK. It's coming to other language SDKs, but probably not there yet, at least in GA. You can refer back to this video later when it's stored in YouTube. But Matias Kuaranta from the Cosmos DB product group has written a couple of pretty good blog posts about that one. So if you are writing a lot of stuff, look at this. And then the peculiarities of the reading. Now this is an example of a document I have in a Cosmos DB right now, and it's just generated from a JSON generator somewhere on the website. Can't even remember what it was, but it generates something like this. So I pushed it in, and when I go to Azure portal and use the Data Explorer, I can search for that document with that kind of a SQL, where ID is Murray Gallagher and so forth. And when I get that, I can check the query stats. Now, the fourth line of retrieved document size says that it's less than 1 kilobyte, but the request charge is 2.9. And the rule was that 1 kilobyte document should be read with a single request unit. What's up with that? We can look at some code to understand the difference. Now, what we have visible here is a C# console application that makes a query with the same information, Mary Gallagher ID, partition key, nothing special. It reads it and gets all the details. And now what becomes visible is the same kind of SQL query we had that is being used by the Data Explorer. And the one below is something that many of us use pretty natively because we are used to doing SQL, right? And we use all the same parameters. Parameters don't change or anything. But the end result is that the first one cost you 1 request unit and the second one cost you almost 3. And why 3? 3 because the SQL API inside Cosmos DB, the SQL engine needs to get up. It needs to start working. It needs to parse the SQL language. And that cost you. So in complex cases, of course, you use SQL API. But in simple cases, if you are right now using SQL API to fetch data from Cosmos DB, stop it. You are wasting 2/3 of the request units. Imagine using only direct read, just getting data with a direct ID, and with $24 a month, you can have a database that performs 400 requests per second. That's pretty cost effective. So Cosmos DB can be cost effective. The issue being that sometimes it's bloody difficult to get there. So for David, this is much win. For writes, because they're predictable, he knows when the device data is incoming, he uses manual scaling and he schedules the scaling so that it's high in the morning and then it's low, very low, in the evenings. And that's cost effective. The reads are unpredictable, but not that demanding like we saw. There was a lot of requests coming to David's machine, David's Cosmos DB, but they didn't use that many request units. Now when he's refactored the reading for simple detail fetching, then it's going to be even simpler. And so David turns on autoscaling for reads because he doesn't know when consumers or users hit the websites or mobile apps or whatever, but he keeps the max value low. In this way, David saves the company. If you look at those numbers, we are talking about tens of millions of request unit usages in mere minutes. He saves the company, I would say, at least 50,000 euros a year. Now, if somebody comes to David, hey, we need to put more oomph to this. There are several things David can look at. He can look at minimizing indexing. He can look at composite indexes if the users or applications are doing order by clauses. He can look at taking reserved capacity. So reserved capacity, it's a billing model. It's not technical. And you just order reserved capacity in the amount of request units from Microsoft for a year or 3 years, and Microsoft gives you 15 to 25% discount on the amount of request units you ordered. So there are plenty of small things David can do. But what we've seen is that these two things, if you check these in your environment, you'll be pretty much golden. Thank you. Now, I think I'll see if there are any questions. So there are two. How would you monitor performance in that case? What is a healthy amount of throttling 429 in that case? Yeah, that's a hard question. Healthy amount of 429s is something that doesn't make you wait too long for your data. So we've seen environments where you might have hundreds of thousands of 429s, hundreds of thousands, and it impacted the performance by a couple of minutes. So don't be afraid of those 429s. Just let them come and see the difference when you scale Cosmos DB up and down. You can scale the request units per second up and down in seconds. So why not use that capability and check it out? Second question, what would be the cost of using Azure functions for copying data between containers? Yeah, there's some cost to copying data between containers. There's two costs. One cost is that copying data with Azure functions via change feed requires that there are these lease containers. so that the Azure functions know which documents they are processing. So they need to store their state in a lease container. And if it's a very busy Cosmos DB, these lease containers can require some request units per second capabilities. But we are still talking about less than 10% of the whole usage in almost all cases, and in most cases a lot less than that, but there's some cost. And depending on Azure functions, of course, in scenarios where this is meaningful, the cost of Azure function or app plans where you would run the Azure functions, for example, are minuscule. Because Cosmos DB, when it goes borked, it really goes sideways, and the cost is so big that couple of new Azure function machines or app plans don't really impact. All right, it was a pleasure being here. There were at least 2 people because those 2 questions were from different people. I hope you enjoyed, and hopefully see you live at some point even this year. Have a nice summer, everyone. Stay safe, stay warm. Bye.